intra-aortic balloon pump is a mechanical device that increases myocardial oxygen perfusion and indirectly increases cardiac output through afterload reduction. It consists of a cylindrical polyurethane balloon that sits in the aorta. Intra-aortic balloon pump was invented by ADRIAN KANTROWITZ. He was an American cardiac surgeon whose team performed the world's second heart transplant attempt on 1967. The intra-aortic balloon pump is inserted percutaneously to the right or left femoral artery. The balloon is positioned in the descending thoracic aorta, 1 to 2 centimeters below the subclavian artery, above renal and mesenteric artery. The benefits of the balloon is from the inflation and deflation. The intra-aortic balloon pump is a volume displacement device. However, it must be properly synchronized with the cardiac cycle. To achieve the maximum benefit, the balloon inflates at the onset of diastole, after aortic valve closure. The inflation point lies at or slightly above the dicrotic notch. The increase in aortic pressure as a result of balloon inflation is called diastolic augmentation. The benefit of diastolic augmentation is the effect of increasing diastolic pressure, and thereby increasing coronary blood flow. In systole, the balloon rapidly deflates just before the systole, before the aortic valve opens. This creates a dead space, effectively reducing afterload from myocardial ejection and improving forward flow from the left ventricle. The balloon is deflated throughout the systole. Initial setup. Number 1. Turn on intra-aortic balloon pump on. Number 2. Open helium tank. Turn towards left. Number 3. Connect ECG cable. Number 4. Connect fiber-optic intra-aortic balloon. Number 5. Connect the intra-aortic balloon. To become familiarized with the parts of the machine, I will show you the actual pictures of the different parts of the machine. This is the helium tank. To open and close the helium, turn the upper portion like the oxygen tank. Going to the right is to close, while going to the left is to open. This is the fiber-optic intra-aortic balloon. This is the intra-aortic balloon. This is the helium gauge. This is the ECG and pressure cable. Pressing the start key automatically purges and fills intra-aortic balloon. Automatically performs an in vivo calibration. Automatically selects most appropriate lead and trigger. Automatically sets inflation and deflation timing. Note, with the Mach-A Datascope fiber-optic intra-aortic balloon there is no need to zero. Calibration occurs automatically after pressing start. Operator may invoke a calibration anytime by pressing and holding zero pressure key for 2 seconds, while assisting. CS300 Operation Modes. Auto Operation Mode. Automatic lead and trigger selection. Automatic and continuous inflation and deflation timing management. User has ability to fine-tune deflation timing. Automatic management of irregular rhythms. Automatic in vivo calibration when using a Mach-A Datascope fiber-optic intra-aortic balloon. Semi-auto operation mode. Operator selects most appropriate lead and trigger source. Operator establishes timing, then CS300 automatically adjusts timing with heart rate and rhythm changes. Automatic management of irregular rhythms. Automatic in vivo calibration when using a Mach datascope fiber-optic intra-aortic balloon. A trigger is the signal the CS300 uses to identify the beginning of the next cardiac cycle. When the CS300 recognizes the trigger event, it will deflate the balloon, if not already deflated. Trigger source keys are only active in semi-auto operation mode. CS300 triggers. ECG. Trigger event is the R wave. Trigger of choice when an adequate R wave is present. Pacer spikes are automatically rejected. Gain can be adjusted while in semi-auto or manual operation mode. Pressure. Trigger event is the systolic upstroke. Trigger of choice with a regular rhythm when an adequate R wave is not present. A fixed pressure threshold can be manually set while in semi-auto or manual operation mode. Pacer V or AV. Trigger event is the ventricular pacer spike. Typically used when ECG triggering is unsuccessful and AV or V pacer is being used. Must be 100% paced. Only available in semi-auto or manual operation mode. Pacer A. Trigger event is the R wave. Recommended only if atrial pacer tails are interfering with R wave detection while an ECG trigger. Only available in semi-auto or manual operation mode. Internal. Trigger event is asynchronous at a fixed rate of 80 beats per minute. Only used when there is no mechanical cardiac cycle, example, cardiopulmonary bypass or asystole. Rate can be adjusted from 40 to 120 beats per minute. Only available in semi-auto or manual operation mode. Theory of counterpulsation therapy. Inflation. Increases supply of oxygen to the myocardium. How it works. Balloon inflates at onset of diastole when aortic valve closes. Displaces blood, causing an increase in aortic pressure. Benefits. Increases coronary artery perfusion. Increases mean arterial pressure. Deflation. Decreases demand for oxygen by the left ventricle. How it works. Balloon deflates just prior to systolic ejection, before aortic valve opens. Results in a rapid decrease in aortic pressure. Benefits. Decreases afterload. Decreases cardiac workload. Increases cardiac output. Timing refers to the positioning of inflate and deflate points on the arterial pressure waveform. Proper intra-aortic balloon pump timing. Inflation occurs at the dichrotic notch. Appears as a sharp V. Ideally, diastolic augmentation rises above systole. Deflation occurs just prior to the next systolic event. Results in a reduction in assisted end diastolic pressure. Results in a reduction in assisted systolic pressure. Timing errors. Early inflation. Inflation of intra-aortic balloon prior to aortic valve closure. Waveform characteristics. Inflation of intra-aortic balloon prior to dicrotic notch. Diastolic augmentation encroaches onto systole, may be unable to distinguish. Physiologic effects. Potential premature closure of aortic valve. Potential increase in LVEDV, LVEDP, PCWP. Increased left ventricular wall stress or afterload. Aortic regurgitation. Increased MVO2 demand. Late inflation. Inflation of intra-aortic balloon after closure of the aortic valve. Waveform characteristics. Inflation of intra-aortic balloon after dicrotic notch. Absence of sharp V. Suboptimal diastolic augmentation. Physiologic effects. Suboptimal coronary artery perfusion. Early deflation. Premature deflation of intra-aortic balloon during diastolic phase. Waveform characteristics. Deflation of intra-aortic balloon is seen as a sharp drop following diastolic augmentation. Suboptimal diastolic augmentation. Assisted end diastolic pressure may be equal to or less than unassisted end diastolic pressure. Assisted systolic pressure may rise. Physiologic effects. Suboptimal coronary perfusion. Potential for retrograde coronary and carotid blood flow. Angina may occur as a result of retrograde coronary blood flow. Suboptimal afterload reduction. Increased MVO2 demand. Late deflation. Deflation of intra-aortic balloon after aortic valve has opened. Waveform characteristics. Assisted end diastolic pressure may be equal to or higher than unassisted end diastolic pressure. Rate of rise of assisted systole is prolonged. Diastolic augmentation may appear widened. Physiologic effects. Afterload reduction is essentially absent. Increased MVO2 consumption due to left ventricle ejecting against a greater resistance and a prolonged isovolumetric contraction phase. Intra-aortic balloon may impede left ventricular ejection and increase afterload. Proper care of inner lumen. Minimize length of pressure tubing. Use only low compliance pressure tubing. Elevate flush bag at least 3 feet or 91.44 centimeters above transducer. A 3 cc per hour continuous flow through inner lumen is recommended. If inner lumen becomes damped, aspirate and discard 3 cc of blood. If unable to aspirate blood, consider inner lumen clotted, cap lumen, provide alternate pressure source. If able to aspirate blood, fast flush to clear pressure tubing for at least 15 seconds with intra-aortic balloon pump on standby. Do not sample blood from the inner lumen. Changing the helium tank. Fully close helium tank valve clockwise. Slowly loosen yoke T-handle counterclockwise. Remove helium tank. Replace washer, if available. Install fresh helium tank. Fully tighten yoke T-handle clockwise. Slowly open helium. Verify full helium level via indicator on monitor display. Note, once the helium alarm sounds, there are 24 autofills remaining in tank. Alarms. Augmentation below limit set. Probable cause. Hemodynamic status has changed. Heart rate, SV, map. Alarm limit set too high. Corrective action. Treat patient. Adjust alarm limit as appropriate. Press augmentation alarm key. Change limit. Autofill failure. Probable cause. Helium tank is closed. Helium tank is empty. Incorrect intra-aortic balloon catheter extender tubing length. Intra-aortic balloon disconnected. Corrective action. Open helium tank. Change helium tank. Ensure only one intra-aortic balloon catheter extender tubing is connected from intra-aortic balloon to pump. Check intra-aortic balloon catheter. Probable cause. Kink in intra-aortic balloon catheter or tubing. Membrane has not completely unfolded. Intra-aortic balloon remains in sheath. Corrective action. Relieve kink if possible. Press start. Manually inflate and deflate intra-aortic balloon. Check the markings of the intra-aortic balloon, and withdraw sheath if indicated. Intra-aortic balloon disconnected. Probable cause. Intra-aortic balloon catheter or extender tubing is disconnected. Corrective action. Reattach intra-aortic balloon and press start. Prolonged time in standby. Probable cause. Intra-aortic balloon pump has been in standby mode for an extended period of time. Corrective action. Verify whether it is appropriate to resume pumping. Rapid gas loss or leak in intra-aortic balloon circuit. Probable cause gas loss has been detected in intra-aortic balloon circuit. Corrective action if blood observed. Stop pumping. Prepare for removal of intra-aortic balloon. If blood is not observed, verify connections are leak-free. With rapid gas loss, resume pumping by pressing start key. With leak in intra-aortic balloon circuit, press intra-aortic balloon fill key for 2 seconds to initiate an autofill, then resume pumping by pressing start key. Unable to calibrate intra-aortic balloon optical sensor. Probable cause. Patient's pulse pressure is inadequate for calibration. Extender tubing or balloon catheter may be restricted. Intra-aortic balloon fill mode is set to manual. Corrective action. When patient's pulse pressure improves, press zero pressure key for 2 seconds while the intra-aortic balloon is assisting. Provide alternate AP source, that is, radial. Relieve restriction. Attempt calibration by pressing zero pressure key for 2 seconds while intra-aortic balloon is assisting. If appropriate, set intra-aortic balloon fill mode to auto via pump options menu. Intra-aortic balloon optical sensor calibration expired. Probable cause. A calibration update has been intentionally postponed because either patient's mean arterial pressure may be too low to pause assist or less than 15 minutes have elapsed since last calibration. Pump is either in standby or the intra-aortic balloon fill mode is set to manual. Corrective action. Assess patient to determine if a brief pause and assist would be tolerated, and if so, Press zero pressure key for 2 seconds while intra-aortic balloon pump is assisting. Provide alternate AP source, that is, radial. Verify that intra-aortic balloon fill mode is set to auto. Resume pumping, then press zero pressure key for 2 seconds to initiate a calibration. AP optical sensing module failure. Probable cause. There has been a failure of the AP optical sensing module in the pump console. Corrective action. Replace CS300, if available. If replacement pump not available, an alternate AP source, that is, radial, must be provided. Contact MACA service for optical module repair. Unable to update timing. Probable cause. Poor waveform quality. Sustained heart rate is less than 30 beats per minute or greater than 150 beats per minute. Poor diastolic augmentation. Corrective action. Check cable connections. Verify transducer was not left vented, if in use. If transducer is in use, aspirate and flush fluid circuit. If problem persists, switch operation mode to semi-auto, verify trigger source, adjust timing, resume pumping. Switch to semi-auto, verify trigger source, adjust timing. If diastolic augmentation is poor, when augmentation level is set to max, attempt to improve patient's hemodynamic status. Intra-aortic balloon optical sensor failure. Probable cause. There has been a failure of the optical sensor in the intra-aortic balloon. Corrective action. Unplug sensor connector and reconnect. If problem persists, provide alternate AP source, that is, radial. Physical assessment. Radial pulses. Left radial pulse weak or left arm ischemia. Corrective action. Check position of intra-aortic balloon. Insertion site. Excessive bleeding from insertion site. Corrective action. Apply pressure, ensure distal flow. Pedal pulses. Limb ischemia detected. Corrective action. Consider removing intra-aortic balloon. Consider insertion via opposite limb. Intra-aortic balloon inner lumen flush line. Pressure waveform damped if using a conventional intra-aortic balloon. Corrective action. Aspirate inner lumen. If line patent, flush for 15 seconds with intra-aortic balloon pump on standby. Urine output. Urine output low. Corrective action. Check position of intra-aortic balloon. Intra-aortic balloon catheter tubing. Blood observed in catheter tubing. Corrective action. Stop pumping and prepare for intra-aortic balloon removal. I hope you learned from my video. Please subscribe and share to support my channel. Press the bell button to be notified with my upcoming videos. Thank you.